All right, recording in progress, I heard. Back to where we were. Okay, so we're here. Again, skip 1.5. All right, so we've gone to 1.6. Quiz tomorrow. So now that you've seen one quiz, you know the way the quizzes work. So I'll show you the quiz, and you have the rest of the day to finish the quiz. 11:59 p.m. officially to submit the quiz. Just take a picture on your cell phone and click, 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 and email it to me. And you'll be doing that for exams and homework. And speaking of that, so the next Friday isn't a quiz, it's a test. So it's a chapter 1 test on Friday the 3rd. So you're responsible for this. You can have one formula sheet, 8.5 by 11, front and back, in your own writing. Put anything you want. Formulas, sample questions, that's fine. You can have a calculator, and you have to turn in this homework. I have a 70% homework rule. You must submit at least 70% of the homework, but that's really a joke because I end up doing a huge percentage of the homework anyway. So you don't really have to do 70% on your own. You do a much smaller percentage, right? Okay, so I was going to finish up 1.4, and then we'll get started on all of this stuff in 1.6 that we have to do. Okay, so we're getting back to 1.4. Let me show you some of the problems at the very end. And then 1.6, we're doing functions. And you've seen functions before, no doubt. You had functions in intermediate algebra. You saw functions in trig. So we'll do functions. But before we get to that, okay, problem 45 from 1.4. I'm going to go over that word problem. And so, yeah, exams are not all word problems, but you can expect some word problems, a representative sample, so to speak. So when I construct tests, I'm not out to get you, quote unquote. But I do want to know that you can do some word problems, but I'm not just going to give you only word problems. Let's see, 45. Determine 3 consecutive positive integers whose sum is 156. Remember doing that kind of word problem? So 3 consecutive integers are x, x plus 1, and x plus 2, you might recall. So 3 consecutive integers, and when you add them up, the sum, x plus x plus 1 plus x plus 2, you get 156. All right, so x plus x plus x, 3x. 1 plus 2 is 3. 156, subtract 3. 3x equals 153. Divide by 3, x is 51. 51 is only the smallest number, so it asks for 3 consecutive numbers. So 51, 52, 53. Right, so those are 3 consecutive integers. And if you add them up, you do get 156, just as was required. Okay. That's that. And when you guys get to calculus, you'll get lots of these kinds of problems that you see, like, these kind of problems that we had. Okay. And let's see, 47 we had to do. So let me show you 47. It says, find the dimensions of the rectangle whose area is 12 and whose perimeter is 14. Area is 12, perimeter is 14. By the way, this is a math class. You could probably guess and get it. If you guess and get it, you don't get credit. I could very easily pick numbers where there's no way you can guess it, right? But you can work it out if you show me the algebra. All right, so the area of a rectangle, I drew a rectangle that's x by y. Area is x times y, so x times y is 12. Perimeter is the distance around. So x plus y plus x plus y, that's 2x plus 2y. That's equal to 14. So I have these 2 equations here. 2 equations, 2 unknowns, and then I need to solve. Okay, so usually what you do here is solve for one of the letters. I decided to solve for y in terms of x, because that's the way we're used to it. Okay, so the second equation, I solved for y. So what I did over here is I subtracted 2x on both sides. That gives me 2y equals 14 minus 2x. Divide both sides by 2. So y is equal to 7 minus x. Then I pick that up and plug it in here. So x times y, here's y, 7 minus x is 12. Then I solve that. 7x minus x squared is 12. I'll make it into a quadratic equation. So I pick all of this up, throw it on the right-hand side, because I'm on a positive coefficient. So I take all this, throw it over. It will be x squared minus 7x plus 12 equals 0. X squared minus 7x plus 12 factors into x minus 3, x minus 4. And that gives me x is 3 or x is 4, which represents really only one rectangle, because if I plug back in, if I plug in 3 here, right, then y would have to be 4. And if I plug in 4, then y would have to be 3. So it's either 3 by 4 or 4 by 3. That's not really a different rectangle. So the final answer is just 3 by 4. Okay, and then 49. But I put this, you can put this down. This is a setup for the next section. Last time I taught, I already put that down. But remember domain and range of a function? Okay, domain is a set of all possible x values in a relation. The range is a set of all possible y values in a relation. So if you want to put this on your next cheat sheet, you may. I was going to talk more about it when we get to functions, but since it's already there, I might as well talk about it. Okay, so domain, set of all possible x values, range, set of all possible y values. If you had to memorize it, because if we were meeting face to face, I make you guys memorize it. It's alphabetical. D is before R in the alphabet, X is before Y. But anyway, that's that. Okay, then I was going to quickly show you 49, and then I'm done with 1.4. Again, we're skipping 1.5. Don't do any of 1.5. Okay, 49. An automobile radiator has 10 quarts of water with a 10% concentration of antifreeze. How much of the liquid in the radiator should be drained? So we're going to drain some antifreeze out and put in pure antifreeze, 100% antifreeze, to ensure that the radiator contains water that has a 30% concentration of antifreeze. Okay, so I've got 10 quarts in my radiator. It's 10% concentration. I drain some of it out. I'll call it X. I pour back in the same amount, X, but it's pure antifreeze. The new concentration is 30%. So the question is, how do I do that? So here's the setup. All right, so if I talk only about antifreeze, I have 10 quarts. If it's 10% antifreeze, 0.1 times 10 is 1 quart antifreeze. So at the start, I have 10 quarts. 1 quart is antifreeze. The other 9 is just water, just H2O. Right? It's 10%. So if I have 10 quarts, 10% is just 1 quart. 1 quart antifreeze, 9 quarts water. All right, now let X be the amount taken out. Okay, so I drain out X. Can you imagine the scenario? Okay, I drain out. So how much antifreeze is taken out? Okay, well, I have 0.1 times 10 minus X is the antifreeze that's taken out. Okay, I have 10% that's taken out. Then I add back in an amount X. That's pure antifreeze, so I don't have to multiply that by anything. It's just X. Okay. And the result is a 30% solution. You have 10 quarts left over, right? So you have 10 quarts with 30%. That means I have 3 quarts total of antifreeze. I'm going to end up with 3 quarts total. So this is my setup. X is the amount taken out. 10% of it is actual antifreeze. Okay, so I have 1 minus 0.1x. If I distribute here, 1 minus 0.1x plus x is equal to 3. Subtract 1 on both sides. Minus 1, minus 1. Negative 0.1x plus 1x is 0.9x. So 0.9x is equal to 3 minus 1 is 2. Divide both sides by 0.9. So x is 2 divided by 0.9, which is roughly 2.2 quarts, or 2.2 repeating. That bar means repetition. So 2.2 quarts, roughly, for 49. Okay, so that's a setup for that one. Okay, and I'm now going to begin 1.6, which is a review of functions. All right, so functions, I've already talked about domain and range, and I don't really like the way the text gives a definition. It's correct, but just think of the domain as a set of possible x values. All the values that x can take on is a domain. All the values that y can take on make up something called the range. Right. They have this, you can look at it or not. I mean, it might confuse some of you. It's correct, there's nothing wrong with it, but the explanation might be a little bit troublesome. Okay, so for a function, you might recall a single x value can only give you one y value. So all of these can only have one number over here. So x1 goes to y1, x2 goes to y2, x3 goes to y3, x4 goes to y3. That's okay. Okay. So nothing here goes to two different values. That's a function. This would not be a function because x3 goes to y3 and also y4, right? So one item here can only go to one item here. So in other words, you're allowed to have a repetition of the y, as you can see here, but you're not allowed to have a repetition of the x. So x3 goes to y3 and also to y4. So that would not be considered a function. Okay. Graphically, on page 39, you might recall the vertical line test for functions, right? So y equals x squared is a function. It passes the vertical line test. X equals y squared is not a function, does not pass the vertical line test. Circle is not a function, it does not pass the vertical line test. Right? So remember the vertical line test. Vertical line test for functions. Right? So if you can draw a vertical line which touches 2 points, not a function. If you draw a vertical line anywhere, okay, and the only possibility is you touch 1 point or less, then you have a function. It's not possible to draw a line which touches 2 points for a function. Here, if I draw a vertical line like right there, it touches at 2, maybe even 3 points, so that would not be a function. Again, their idea of domain and range, I don't really like the way they say it. It's correct, but I think it's easy to just go by this. Domain, set of all possible x values. Range, set of all possible y values. Now, the homework looks like a pretty long assignment, but some of them are pretty fast. 5 to 14 is very fast. In fact, I'm going to knock those off right now. And I think 1 and 3 aren't that bad either. So let's see what we're talking about. Okay, odd and even functions. We talked a little bit about this before. Page 44. This is worth putting on your cheat sheet, your formula sheet. A function is called even if, it's probably easier to look at this, f of negative x is equal to f of x all the way through. So even though this is true, I might say a function is even if f of negative x equals f of x. If you replace x by negative x, you get the same thing back. You have an even function. Even functions have y-axis symmetry. So this is an even function. Y-axis symmetry. A function is odd if, and I would exclude all this, if f of negative x is equal to the opposite of f of x. So a function is odd if f of negative x is negative f of x. So if you replace x by negative x, you get the exact opposite of what you started with. And the graph of an odd function has origin symmetry. So here's an example of origin symmetry. Right? We've seen that before. Right, so even function, y-axis symmetry. Replace x by negative x, you get an equivalent equation. Odd function, origin symmetry. If you replace x by negative x, you get the opposite of what you started off with. And here's an example of neither. It's neither odd nor even. So unlike integers, numbers, right? They're either odd or even. So if I say 7, you say odd. If I say 12, you say even, right? It's either going to be odd or even. That's not true for functions. A function can be neither even nor odd. So this one doesn't have any symmetry, right? There's no y-axis symmetry. There's no origin symmetry. Okay, so definition of odd and even. And in case you're wondering, you might say, what happened to symmetry with respect to the x-axis? We normally don't talk about that because if you have symmetry with respect to the x-axis, you probably don't have a function. Right now, we're talking about functions. Okay, so this, right? X-axis symmetry. Excuse me. X-axis symmetry. Right. Well, you're probably not going to have a function. It doesn't pass the vertical line test. So right now, we're only looking at functions. So for functions, we're almost never going to worry about x-axis symmetry, either y-axis symmetry or origin symmetry. Okay. All right, so on page 45, so there's a nice little summary here. Domain, unless specified otherwise, this is the largest set of numbers for which the function is defined, which means you start off with all real numbers, and then you throw stuff out, as the case may be. And I'll show you what we mean by that. Okay. If you're given a graph, you're just saying x going this way. What values can x take on? Range, we're going up and down. What values can y take on? And we've talked before about intercepts. Okay, so here y-intercept, x equals 0. X-intercept, y equals 0. So we've talked about that before. And we just talked about symmetry. So even functions, f of negative x is the same as f of x. Origin symmetry, odd functions, f of negative x is the opposite of f of x. And I'll give you examples of all these. Okay. And yes, they give us some word problems. We'll look at some word problems. But now for the homework. So starting on page 50, so for the benefit of those of you who don't have the book, I'll show you this, and this, and this. Name it there. And that. And that. Okay, and how high did we have to go? I had to go to 73, so there's a lot more. That. And that. And I don't have to hold it that long because you can always pause the video. Okay, then on the next page, and yeah, I see some word problems that are there that we have to do. And there. Yeah, 59, it says 10 knots there. I'm going to change it to miles per hour. You might not know what is a knot. It's a nautical term, but it doesn't change the problem significantly if I change it to miles per hour. And we're probably more comfortable with miles per hour. So instead of 10 knots, let's make it 10 miles per hour. It doesn't really change the problem that much. And I'm not sure if I showed you this side, so let me show you this side again, just in case. Okay, then we had to go all the way up to what? 73. There's that. And that. And that. Yeah, I think that does it. Okay. Let's knock off the graph ones right away. So we had 5 and 6. By the way, this is functional notation. You remember called the F business, right? So f of x means a function. So f of 2 means plug in 2. F of x plus h means you plug in x plus h. And I'll show you several of those. Let me do 5 and 6. Let me do 6. And for 6, at least in my book, I think there's a mistake. It seems to go blue right up there. Let's assume it's not there. Okay, so I'm going to say the graph goes right up to -0.5 and not there. My graph, it looks a little bit bluish. I'm going to assume it's not there because if it's there, it's not even a function. So I will make the assumption it goes up to here, closed circle, nothing there, open circle, and then continues on like that. Okay. All right, so when it says f of blah, 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 it means when x is that value, what is y? So f of -1 means when x is -1, what's y? So in this case, it looks like -1.5. So I'm going to say this is -1.5. It'll go like this, -1.5. F of 0. F of 0, that's an open circle. I'm going to go to the closed circle right there. That's -0.5. -0.5. So when x is the number in parentheses, what's y? F of 1, that means x is 1, y is 2. F of 3, 0. Right? All right, then as for the domain and the range, I'll abbreviate with D and R, the domain and range. So domain, set of all x values. So let's see, starts right there about -3.5, right? And comes all the way, includes 0 and stops at 3. It includes -3.5. It includes 3. So I'm going to say bracket -3.5, comma 3 bracket. So all the numbers from -3.5 to 3, including the endpoints, are in my domain. The range is a little bit tricky. I'm going to say it stops right there. Again, I'm going to pretend that blue part isn't there, otherwise you wouldn't have a function. So from -4 to -0.5, so -4, -1/2, include -0.5. And then from 0 up to 2 point a little. I mean, this is kind of tough. Let me say it's 2.2. So union 0, 2.2. I'm going to say that's my range. 0 is not included here.
0 though, right?
0 is not included here, but 0 is included here. So 0 is in the range. Okay, so -4 up to -0.5, including both endpoints, union 0. Yes, there's no y value of 0 here, but there is a y value of 0 here, and we're going up to 2.2. Yes, question? Good question? Okay. So that's that. Okay, let me quickly knock off the 5 to 14 all. So that means I'll show you the evens, right? It's just, is it a function or is it not a function? So we're just looking for the vertical line test, right? If you can draw a vertical line which touches 2 points, it is not a function. If it's not possible to draw a vertical line which touches 2 points, it is a function. Okay, so number 8. Number 8 is or is not a function. Looks like it's not a function, right? I can draw a vertical line which touches 2 points. So 8 is a no. 10 is a circle. So it's a circle function.
Can you actually do, I know you wanted to skip it, but could you do 9 really quick? Because like I got kind of confused because at one point it looks like that it could touch, like it just stays touching number 9.
Yeah, it doesn't. But yeah, let me finish what I was doing.
Okay, sorry.
Okay. So 10 is a no. And 12 might answer your question for 9 also. Okay, the assumption for 12 and 9 and 11 is it doesn't actually become vertical. It keeps getting really, really, really close. It never quite gets vertical. Likewise here, you have an asymptote. It gets really, really close, but it never becomes vertical. Okay, so 12, we're going to say is a function. So that is a function. It never really becomes vertical. And therefore, likewise for 9, 9 is a function. It never becomes vertical. And in fact, that same concept is 14 also. So 14 is a function. Okay, it never becomes straight up and down. It gets really, 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 really close. It doesn't quite touch it. So 14 is a yes. 12 is a yes. 10 is no. 8 is no. In fact, one more like that would be 13. Get this thing focused here. Is 13 a function? Okay. The only real question is right here. That's a closed circle, means count the point. Open circle, don't count the point. So is it still going to be a function? If I draw a vertical line right on the y-axis, does it touch more than one point? No, it does not. So 13 is still a function. 13 is a function. However, if I colored in this point also, and that's closed, I would not have a function. Because then if I drew a vertical line right on the y-axis, it would touch 2 points. But since this is open and this is closed, it's still a function. And by the way, if they were both open, it's still a function. Right? The rule is, if I draw a vertical line, I'm going to touch at 0 or 1 points. Then it's going to be a function. You're allowed to touch nowhere. So 13 is a function. So that knocks those off. And then the other graphical ones were for even and odd. Let's see. We had 51 to 54 all. Let me get those out of the way. So even, odd, or neither even nor odd. So we look for symmetry with respect to the x-axis and the origin. Okay, we can knock them all off. Okay, 51. 51 looks like we have what kind of symmetry? Y-axis symmetry. So 51 is even. Okay, so we want to put that down in your notes. 51 is even. How about 52? Let's see. That also looks even. Right? So 52 is also even. 53. Oh, my nose here a little bit. 53. Well, do we have symmetry with respect to the origin? If we did, this point would have to have a corresponding point here. It doesn't. And we don't have a symmetry with respect to the y-axis. So 53 is neither. 53 is neither. And 54. 54 is odd, right? So a point reflected across the origin comes here, and this one would come here, and this one would come here, and so on. So 54 is a reflection across the origin. So 54 is considered odd. All right. Okay, let's see, what time is it? Okay, review of how to do some of these functional notation ones. Okay, so back to problem 1. F of x is blah, 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 and then you just plug in and do whatever it says. Starts off easy and then gets a little bit harder. Okay, so I'll show you some of these, A, B, C, D, E.
Could you possibly review some of the quotient differences one? Like I got how to do it. I know how to plug it in, but the last part it wants us to express it and as h approaches 0, and like some of them are like fractions, and I really didn't know how to do that.
I'll show you those.
Okay.
Get to them.
Okay.
So I might not get to it today, but we'll see. Okay, f of x is 2x squared plus 3. Okay, 1b says f of radical 3. That means right here, put radical 3. So we're doing radical 3 squared. But what is the square root of 3 squared? When you have a square root and you square it, you just drop the square root, right? So it's just 2 times 3 plus 3. So 6 plus 3, 9. So the final answer is 9. A little bit harder is f of 2 plus radical 3. Okay, so right here where it sees x, continue, erase it, and put parentheses, 2 plus radical 3. So it's going to look like this. 2 parentheses, 2 plus radical 3 squared plus 3. Okay. And then I do my formula for the square of a binomial. We call a plus b squared from algebra is a squared plus 2ab plus b squared. So here, leave the 2 alone. 2 squared, a squared is 4, plus 2ab. 2 times 2 times radical 3. So 2 times 2 is 4, 4 radical 3. Plus b squared, radical 3 squared is 3. And then I add 3 at the end. So now it's just some touch up. I distributed the 2. 2 times 4 is 8. 2 times 4 radical 3 is 8 radical 3. 2 times 3 is 6. And then I still have a 3. So 8 plus 6 plus 3 is 17. 17 plus 8 radical 3. Okay, h. F of x plus h minus f of x. That crazy thing. And when I see that, I'm chuckling a little bit. And the reason why I'm chuckling a little bit is because they're setting you up for calculus. You're going to see this expression quite a bit in calculus. So that's why we're doing it now in pre-calculus. Okay. So when you get to calculus, you're going to see that f of x plus h minus f of x quite a bit. So they're getting you used to that expression, I suppose. So how do I do that? Where'd it go? So f of x plus h means right here, erase the x, put parentheses, x plus h. So it's 2x plus h squared plus 3. And then minus the f of x. Well, f of x is the original. So just copy 2x squared plus 3, but it has to be in parentheses. So the hard part is the f of x plus h. 2 parentheses x plus h squared plus 3 minus parentheses f of x, 2x squared plus 3. So now I just do that heavy-duty algebra. So let's see. 2 times x plus h squared is this, x squared plus 2xh plus h squared. And leave alone the plus 3. Distribute minus 2x squared minus 3. And I distribute 2 times that. 2x squared plus 4xh plus 2h squared. Copy the rest of it. And then it looks like the 3's cancel out. 2x squared cancels out. So all I have left is 4xh plus 2h squared. Okay. Right, so that's how to do those kind of problems. Just plug in. So I did several of those problems. You take it from there. Okay, I wanted to jump over to do a domain and range kind of problem. So starting with 15, find the domain and range of the function. So you may have to graph it to see what's going on. Okay, so let me show you 19, x squared minus 2x plus 1, number 19. X squared minus 2x plus 1 turns out to be x minus 1 squared. Well, I know what x squared looks like. X minus 1 squared just shifts the graph 1 over to the right. So it looks like this. Graph the opening up. The vertex is at 1, 0. By the way, what do you get when you plug in 1? It's 0, right? So it looks like this. So what's the domain of the function? How far does it go in the x direction? Well, it goes infinitely far to the left and it goes infinitely far to the right. So the domain is all real numbers. So one way you can write all real numbers is this funny looking R, put 2 marks like that for R. Another way to write all real numbers is to go from negative infinity to infinity, right? You're going all the way to the left and you're going all the way to the right. So the domain is all real numbers, or you can say negative infinity to infinity. I like this, it's short.
Got a question
Range,
for you.
what's a set of possible Y values? Okay, so I don't have any Y values down here. The lowest Y value is 0, and I go up, 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 up. So the range is bracket 0, infinity. So all the numbers from 0 to infinity. Yeah, somebody had a question?
Yes, what does it mean okay, so, oh, I see, I think I got it. So when you do x squared minus 2x plus 1 is equal when you factor that out. As,
Right, in fact, I noticed that it was
got it,
x minus 1 squared. That
got
makes it
it,
easier for me to graph.
got it.
So,
Okay, so you can do either way, right?
yeah, well, in this case, it's probably easier to look at the graph so you can see what's going on. In fact, if I just look at this, I can't really tell the range. But when it's like this, it's a little bit more obvious.
Okay, but I mean, in terms of the quiz or exams, either way is valid, right?
I'm
Or
not sure what you
what
mean
type of
by
output
either
could you
way.
expect?
You can't really tell from this. So you should factor this one, in other words, is what I'm trying to say.
Okay.
To get the range especially.
That is correct, because normally what I do like x minus 1 times x minus 1, and I just find x minus 1 is equal to 0, which is x equals to 1.
Right.
Yeah.
So that gives
Yeah,
me
got
1,0. Yeah, that works.
So we do find in this particular case domain and range only, right?
The question was to find a domain in range. Yeah.
Got it.
So
Got it. So are these covering only quadratic and linear, or also like you know, like even like x to the cube or x to the 6 and stuff like that?
yeah, yeah, you should know something about other functions too. Like there's a square root there, and
Got
there's
it.
this weird
Yes, I
piecewise
got that.
defined function that I'll show you also.
So
those are definitely part of it.
is the exam involves piece of defined function or what?
These are all functions.
Yes.
But, yeah, so for like 21, I'm about to graph it. You can't really tell unless you know what the graph looks like. So
I got it. Yes.
yeah. So let me graph that.
Sure.
21 is split into 2 pieces. F of x is 1, where x is greater than or equal to 0. And by the way, remember this is y. When you write f of x, it's the same as y. Y equals -1 if x is less than 0. Okay, x is greater than or equal to 0, horizontal line, y equals 1. But for x less than 0, you're down at -1. So the graph looks like this. This is like saying y equals 1, y equals -1. Those are horizontal. But it's only valid here when x is greater than or equal to 0. So closed circle here, open circle here, and we go like that. All right, so again, what's the domain? How far does this graph go left and right? Well, as far as you want. So the domain is all real numbers. The range is just 2 numbers. So braces, -1, 1, and the braces indicate that you have a set. Don't write it as an interval. So you cannot write brackets or parentheses, because when you write brackets or parentheses, you're counting everything in between. When you're not counting everything in between -1 and 1, you're only saying -1 and 1, period. So you indicate that with braces. Braces are used to indicate a set. Like this.
How could you do that in a like a notation?
I'm sorry, I didn't hear.
I mean, when you write it as notation, I remember I used to do like negative, not included, negative infinitive to -1, not included, union, and then
not
a
include, that's going to
bracket.
be too difficult to throw out that set. So just do it like this.
Oh, okay, got
Because
it.
I know you know, we try not to be negative whenever possible. Say don't include negative infinity and -1. That's too complicated. Right?
Yes.
So just say this is very easy. -1, 1, I get it. But if you're saying real
Got it.
numbers, throw out, then no, that's much too difficult.
Excellent. Okay, so then I won't do the notation then.
Yeah, just use this notation.
Got it, got it. Yeah, because in other cases, I was asked to do the notation, so that's what I was.
Yeah, don't do it for me.
Got it, understood.
It's a lot
Thank
easier,
you.
I think.
Thank you.
Okay, all right, you're welcome. Okay, so let me go back and do 5. There's only one problem like that. Okay, determine the values of f of -1. Okay, so it means when x are these numbers, what's y? So I'll just do maybe a couple of those. I'll do the first and last one. How about that? F of -1. When x is -1, what is y? Looks like 0. This one is 0. And how about the last one? 3. F of 3 means when x is 3, y is here. So that looks like -2. Okay, then it asks for domain and range. So domain, does x go forever to the left and right? No, it doesn't. X only goes from here to here. So that looks like from -2 to 3, counting -2 and counting 3. So the domain is bracket -2, 3 bracket. And it looks like the range, I got the same thing. Bracket -2, 3 bracket. Let's see how come. So the range, that's in the y direction. The lowest y value is here, -2. The highest y value is 3. And I'm including both endpoints and everything in between. So yes, for this particular one, both the domain and range are the same thing, bracket -2, 3 bracket. All right, just do one more and then I'll stop. We'll go to problem 25. Determine a number a in the domain of the function with f of a equal to b for the given value of b. Okay, so what are they talking about? So square root of x minus 1, b is a half. They're just saying set this equal to a half. The words are kind of funny. But find a value of x so that this is a half. So in other words, square root of x minus 1 is equal to half. Solve. Make that equal to half. So how do I get with square root? Square. Square both sides. X minus 1. 1/2 squared is 1/4. And then just add 1 to both sides. So 1 and 1/4.
Could you remind me really quick when do you take plus or minus answers in respect to square roots and squares?
Okay, so plus or minus. If you're taking the square root property, like x squared equals 9, I have to ask myself, 3 works, but does -3 work? Yes, it does. So by the square root property, whenever you're taking a square root, you need a plus or minus, but not when you square. When you square both sides, you don't need a plus or minus. So that's so. Okay.
Do you need
Folks, that's as much as I was going to do for today.
in this
you're
one?
welcome to ask questions for the last few minutes. So we're up to 1.6. I'll continue with 1.6. Again, I'll give you a quiz tomorrow, and it's due at 11:59 p.m. tomorrow, Friday. And I'll continue on with 1.6. We have 1.7, 1.8 left, and then our first exam is next Friday.
So quiz is 1.3 to 1.6.
Quiz is everything that we did this week. That's fair game.
Got it.
Mm-hmm.
Yeah, which is 1.3 to 1.6.
1.3 to 1.6. Yeah.
Got it.
No 1.5 though. Yeah, we didn't do 1.5.
Okay, 1.3, 1.4, and 1.5.
No 1.5.
I'm sorry, 1.3, 1.4, and 1.6.
The easiest way is just say everything this week. Okay.
Yes.
And that's the way it's always going to be, just week by week.
Got
Yes,
it.
somebody else had a question? Let me check the chat. Okay, I don't see anything in the chat. Okay, so any other questions, please? Otherwise, that's it. All right, then we'll call it a day. All right, so we'll see everybody tomorrow and have a good day, everybody. Okay, bye.
Thank
everyone.
you.
Thank
Thank you.